Sir.
Hello, is my screen visible?
Yes, sir.
Okay. So last day we have taught about Gauss's law. Mm, We have taught of Gauss's law. There we have found that flux passing through a closed surface that was equals to q encircled enclosed. So d dot ds, its integral form was d dot ds mm, over a closed surface that will be is equal to rho v dv rho v dv over a volume. And you know from the Gauss divergence theorem that any surface integral can be related with the volume integral, which is equals to del dot d del dot d dv over a volume integral mm, rho v dv. So from there we can calculate del dot d is equal to rho v. So we have taught this. We have seen these aspects. We have seen these derivations previous day. This form is called this form of equation is called integral form of Gauss's law. This form is called integral form of Gauss's law, and this is called differential form of Gauss's law. Okay. This is integral form. This is integral form. And this is called differential form. So I'll shortly demonstrate a problem on this theory. This is all about Gauss's law and physical interpretation of Gauss's law and the concept of divergence and the relevancy of the divergence to this theorem. I have already explained in the previous class. Okay, so I am not discussing that again. Am I audible clearly? Am I audible clearly? Okay, okay. So now I'll show you a problem. I'll show you a problem that will demonstrate this statement of Gauss's law. You see this problem. Given that D, that means your uh, D means your flux density. Your D means its flux density. It's a vector. Hmm. It's a vector. It's z r cos square phi z r az coulomb per meter square. It's unit. It is given flux density. Flux density is given by this ZR cos square phi AZ cap. As we calculate the charge density at 1 pi by 43, you need to calculate charge density, that is rho v at 1 pi by 4 3. Okay, you need to calculate this. And the total charge enclosed by the cylinder of the radius 1 meter with this region or with this barrier. So let us first solve this rho v. So you know this straight away, this you use this formula del dot d is equal to rho v. So you know what is del dot d. It is the divergence. So and the problem is given in the cylindrical system. So you should search for cylinder divergence in cylindrical. So you know this formula 1 upon h1 h2 h3 1 upon h1 h2 h3. Thereafter a square bracket starts del del u1 del del u1 del del u1 a1 h2 h3 a1 h2 h3 plus del del u2 a2 h3 h1 plus del del u3. So this was the formula del del u3 of a3 h1 h2. Square bracket ends. So you know in the cylindrical system h1 and h3 are all 1, h2 is 1 by r, so it will be 1 by r. And you know it's only z component is existing, so these two terms will not be uh, will not exist anymore. Okay, since r component and phi component does not exist, so the third component will be the existing component will be del del z of a3. So you see the a3 is only this much, zr zr cos square phi. Okay, and h1 h2, then h1 h2. So what is h1? H1 is 1 and h2 is r. So this is the result. So del del z of zr cos square phi, it will be uh, r cos square phi, so r square by r, so it will be resulting r cos square phi. So del dot d, you will get the result del dot d, the result will come as uh, r cos square phi, r cos square phi. So your rho v, which is definitely, you know, it's equals to del dot v, del dot d, r cos square phi, r cos square phi. Now you need to evaluate at this point 1 pi by 4 3. So it is 1 into pi by 4 cos square So it will be half. So it will be coulomb per meter cube. So this is the result, rho v. It is volume charge density happens to be 0.5 coulomb per meter cube. It happens to be coulomb per meter cube. Okay. Any doubt till this? Any doubt, please? Anything? Any doubt? So if there is no doubt, so we can proceed further. So this is the volume charge density is evaluated as evaluated 1 by 2 or simply 0.5 coulomb per meter cube. It is volume charge density. So after that, what was the statement? You see, the total charge enclosed by the cylinder. Now total charge, you need to evaluate the total charge enclosed by the cylinder of radius 1 meter with this range. So you need to integrate this expression del dot d. So total charge so r cos square phi. So rho v is r cos square phi and dv, you know, in the cylindrical system differential volume element is r dr d phi dz. So now you need to insert your limit. So you know it's r from, you see the range is cylinder of radius 1 meter. So r must be from 0 to 1. Then phi starts from 0 to pi, 2 pi. And z starts from -2 to +2. So this should be the range. So r from 0 to 1, phi to 0 to 2 pi. Now you can evaluate this integration. Anybody? So it will be r square cos square phi dr d phi dz. So now you can integrate. You see r square dr r cube by 3. So it will be 1 by 3. If you integrate the only r, so it will be 1 by 3. Right? If you integrate z, it will be z. So 2, it will be only 4. So dz, if you integrate dz, it will be z. So it will be 2 minus of -2. So it will be 4. Now, as far as this cos square phi is concerned, so you know what is the integration of cos square phi? Can anybody tell me? Can anybody tell me what is the integration of cos square phi? Are you with me? So it I think half into 2 cos square phi, so it will be, please tell me, 2 cos, so can anybody tell me 2 cos square phi means?
1 plus cos 2 phi.
1 plus cos 2 phi. One plus cos 2 phi. Good. That means you know cos 2 phi. The formula was cos square phi minus sin square phi. Cos square phi minus sin square phi. So from sin square phi you can retain 1 minus also. Yes, 2 cos square phi minus 1. So it will be 1 plus cos 2 phi, right? So now you see half. Now cos 2 phi, if you integrate this cos 2 phi, so let it write it down from phi to 0 to 2 pi. Cos square phi 1 plus cos 2 phi, then it comes to d phi. Now outside 1 half will come. So now 1 into d phi. So you see, if you integrate this one, then the integration of the second term will be 0. Okay, second term the integration will be 0 because it is integrating over a complete cycle. So sorry, cosine phi will be like this. So exactly positive cycle, exactly the cancels out the negative cycle. So integration of cos 2 phi from 0 to 2 pi is 0, and if you integrate 1 into d phi, so it will be only 2 pi. 2 pi. uh, so the ultimately answer will be mm, so 2 by 3, 2 by 3 into 2 by 3 into, now this is 2 pi, so 4 pi by 3. So it will be answer 4 pi by 3. Unit is coulomb. Okay, so this is the problem. 4 pi by 3 answer. You see, it is given, it's 4 pi by 3 coulomb. It is given in this note. So you go through this problem, you can please let me know if there is any question or not. Anything? Any doubt? Any doubt?
স্যার কোশ্চেনটা একটু দেখাবেন, ওটা নোট করে নিতাম।
Okay, 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 okay. I did I share this with you? This copy of this PDF file? I believe I shared it. Sorry, did I share this with you? I did not. Okay, I'll again send it. So you please, I'll give you 2 minutes time. You copy this. So did you copy? Have you noted down? Should I proceed for further topics? Hello?
Yes, sir.
Yes, sir. Completed now.
Okay, okay. Thank you. So further, so let us come back to our topic that we have first started with Coulomb's law. We have started with Coulomb's law. There, from the concept, from the Coulomb's law, we have introduced the concept of E. Force. First of all, we have introduced the concept of force. There, from there, we have introduced the concept of force per unit charge, which is nothing but E, which is called electric field intensity. From there, we have introduced the concept of flux density and flux. Okay, flux density and flux. From there, we have come to the conclusion of charge. Now, we shall see a very familiar topic which is called potential. What is potential? Now, to define the potential or simply potential of any point, it is defined by, let me show you the definition. Electric potential of any point electric potential of any point is defined as the amount of work done to bring an unit positive charge from infinity to that point. Okay, this is the definition of electric potential. So you need to bring one amount of unit positive charge from infinity to that point, and in doing so the amount of work done will be treated as your electric potential. Now you can see this. You please see this diagram. In figure 2, a charge Q is to be brought from A to B. Suppose this is A and this is B. Sorry, this is A. Let us say this is A point. This is B point. So a charge needs to be brought from A to B. Now this electric field is E. Now work done to carry this charge, it's defined as W. Let me write it down, then I'll explain. E dot dl from A to B. So it is a mathematically written expression for work done to move a charge from position A to position B. Now, if you integrate E dot dl, it will definitely it will create a force. Sorry, it's E dot dl. You need to carry the charge from A to B. Now, why this minus sign? Because the work is done against the electric field. So again, VAB, similarly, VAB, it is the work per unit charge. So it will be minus A dot A to B, E dot dl E dot dl okay. So it is the exactly the same relation. VBA is the just reverse, minus of VBA integration of B to A E dot dl. So if you add them, then VAB plus VBA, it will be simply, you can write E dot dl, that will be is equal to 0. So this is a very crucial expression. E dot dl, line integral of E dot dl over a closed line is it 0. Now, as per the Stokes theorem, as per you, if you recollect, it will be del cross E dot ds, it will be 0. So from there you can write del cross E is 0. So this one is a very crucial expression. That is why it is called electric fields are always irrotational fields. Electric fields are always irrotational fields. Okay. Electric fields are irrotational one. So this is the exactly the same thing, it is written here. Okay, so if you If you have any question, you can ask me. So this is a very important derivation. Del cross E is equal to 0. That signifies that electric fields are always irrotational. So if you are given a vector and if its curl is 0, then you can say that, or you can immediate draw a conclusion that this field must be an electric field. Later, for the later stages of this course, I will show you that in case of magnetic field, the divergence of the magnetic field will become 0. Divergence of the magnetic field will become 0. So if a vector field is there, if its curl is 0, then it must be an electric field, and if its divergence is 0, then it must be an magnetic field. Okay, so I am giving you 2 minutes time. If you can ask me anything, you can. Most welcome. You are most welcome. Please ask me. If you have any query, please ask me. So if there is no question, I shall proceed further. Let us show you the example. You see this problem. Before that, I must show you the relation between E and V. That means electric field intensity and potential. It's a very important relation. Are you there? Are you there? Hello?
Yes, sir.
Okay. So let us derive the expression of E and the relationship between E and V. So you know, as per the previous page, dV or the potential is minus E dot dl. It is the fundamental relation. Okay. So now you can say that we can break E and dl in both the vectors. We can break it. So E can be broken by Ex Ax cap plus Ey Ay cap plus Ez Az cap dot dx. Now dl can be brought or dl can be broken It can be split into three components: dx ax cap plus dy ay cap plus dz az cap. Okay, so now if you multiply them, they will generate ex dx plus ey dy plus ez dz. Okay, again db can be written del v del x dx plus del v del y dy plus del v del z dz. So if you relate these two relation, if you relate these two relation, okay, if you relate these two relation, you can compare, you can directly write it down. So you can directly write it down. You see ex that will be minus del v del x ey that will be is equal to minus del v del y ez that will be is equal to minus del v del z. So by comparing these two, by comparing this one and this equation to equations given in the star mark, we can write ex is equal to minus del v del x, ey is equal to minus del v del y, and ez is equal to minus del v del z. Okay, so again we can write e as, again we can write e as ex ax cap plus ey ay cap ez az cap. Okay, so what is ex? Minus del v del x ax cap minus del v del y ay cap minus del v del z az cap. We can write it down like this. So if you take this v outside, then this equation will be looking like del del x ax cap plus del del y ay cap plus del del z az cap into v. Now this thing you can treat as del. that is the grad operator. So the final relation you can write E is equal to minus of del dot V. So this is the final relation. E is equal to minus del dot V. So it's the nothing but it's the negative gradient of potential. Electric field intensity is nothing but negative gradient potential. So now the next problem, you focus on this problem. A potential function is given, V is equal to a potential function given, V is equal to 10 by R square sin theta cos phi in the first part. Find the electric flux density. Okay, find the electric flux density. You need to evaluate the D at 2 pi by 2 0 2 pi by 2 0. Okay, so let us solve that. So you know you have V. From there you need to evaluate E, and from there you need to evaluate D by applying Gauss divergence theorem. So let us do that. E is equal to minus del dot V. Now this problem you must understand that it's a theta and phi both are there, so this problem is given in spherical system. So you need to look the spherical formula, or it's the gradient in spherical system. So let us show that. So this is the gradient. Okay, so general formula. So del dot V. So it will be minus of a square bracket. If you put 1 by H1 del V del U1 1 E1 plus 1 by H2 del V del U2 E2 plus 1 by H3 del V del U3. So this is the general formula. So if you now put one by one, so in the spherical system H1 is 1, H2 is R, and H3 is R sin theta. You should know this. So this will be adding the values in spherical system, right? This will be adding the spherical system. So let us write it down. So 1 by H1, that means 1 by 1. So del R of 10 by R square sin theta cos phi. Then you must, E1 means the unit vector, so you must put AR cap. Plus 1 by H2 means 1 by R. Then you put del V del theta 10 by r square sin theta cos phi. You must put the unit vector a theta phi, and the last term remains 1 by r sin theta del v del phi 10 by r square sin theta cos phi. So this is the, you must end the square bracket. So I made a mistake. You should avoid writing del v here, because it's a del theta of v. So I have put the v is equal to here in within the first bracket. So if you evaluate this e, the result will be coming as result will be coming as 20 by r cube. Result will come as 20 by r cube sin theta cos phi ar cap minus 10 upon r cube cos theta cos phi cos theta cos phi a theta cap, then plus 10 by r cube sin phi a phi cap. So this is e equals to, we have evaluated e is as that much. So now what is d? So you know d is equal to epsilon e. So you know the epsilon value 8.854 into 10 to the power minus 12 into this e. I am not writing it again. So this must be at 2.2 pi by 2 0. So if you put the value r is equal to 2, theta is equal to pi by 2, and phi is equal to 0, the ultimate answer will come 22.1 pico ar cap picocoulomb per meter square. So this is the answer at this point, provided after evaluating e we have substituted r is equal to 2, theta is equal to pi by 2, and phi is equal to 0 in this expression, in this big expression, and after multiplying it with 8.854 into 10 to the power minus 12, we are getting 22.1 ar cap. Its unit must be picocoulomb per meter square. So once you have got E, you have evaluated D. There the first part is over. So please tell me if there is any question. I am giving you 1 minute time. Go through this expression and please let me know whether is there any question or not.
স্যার কোশ্চেনটা একটু দেখাবেন?
Sure. Now the second part is quite interesting. Now calculate the work done. Calculate the work done in moving a 10 microcoulomb charge from position A to position B. The second part is quite interesting. Suppose you have a point A here. The location of the point A is 130 degree, 120 degree. 130 degree. Look here, we're getting here 120 degree, and you have B. Okay, so you can see that type of plus sign. So you will select any point on the root plus 490 degree, 60 degree. 490 degree, 60 degree. So you need to traverse charge. Its magnitude is 10 microcoulomb. 10 microcoulomb charge, you need to traverse it from A to B. In doing so, you have to calculate what will be the amount of work done. Okay? So to do that, you require this expression E. So let me write it down again. E is equal to E is equal to 20 by R cube. 20 by R cube sin theta cos phi. So now, if there is sin theta cos phi AR cap minus 10 R cube 10 upon R cube cos theta cos phi cos theta cos phi A theta cap plus 10 by R cube sin phi A phi cap. So this is E. So we require this because you know work done is E dot dl. So now we shall take this problem into three different stages. First, we shall move this charge to a new point X. Means I am telling you that I want to tell you that instead of moving in this direction, we shall take different route. So first we shall take this 10 microcoulomb charge from A to X such that the location of X is 430 degree 120 degree. Okay, so the location of X is 430 degree 120 degree. So thereafter we shall take this charge again at another new point. Let us say that point is Y. the location of that y would be 4, 90 degree, 60 degree. Okay, and after that finally we are taking that in our final point the location of is 490 degree 60 degree. So what is happening is that you please keep this in mind, or you please understand, we are what we are doing actually is we are changing one parameter at a time. You see, one a2x we are changing only r, keeping theta and phi constant. Okay, again when we move from x to y we are changing theta, however r and phi remains constant. Sorry, it will be 120 degree. It will be 120 degree. Again from y to b we are changing only phi, r and theta remains constant. So in doing so, what is happening in that from a to x the differential line element will be dlr, and from x to y differential line element will be dl theta, and from y to b the differential line element will be dl phi. Okay, so we arrange this expression, it's like this. So total work done W, that will be equal to minus of Q definitely. Now that integration, the total integration must be carried into three different parts. The first integration should be carried at E dot dlr E dot dlr. Okay, from you should integrate r from 1 to 4. Okay, at this, when you do this integration you should keep theta is equal to constant at 30 degree, and you should take phi is equal to constant at 120 degree. Okay, our second integration should be E dot dl theta. So theta must be varying from 30 to 90, 30 degree to 90 degree. When you do this integration, your r should be fixed at 4 and phi should be fixed at 120 degree. And the third part of the integration will be E dot dl phi. So phi should be varying from 120 to 60. So r is equal to 4. It should be constant at r is equal to 4, and theta is equal to 90. Okay, so in this way you have to carry out this third integration. So let us assume this one as I1, let us assume this one as I2, let us assume this one as I3. So you see that in I1 only dlr will be there. So I1 integration integration from R to 1 to 4 E dot DLR theta is equal to 30 and phi is equal to 120. Theta is equal to 30 degree and phi is equal to 120 degree. So now since this DLR a component only existing, so these two, that means a theta component and a phi component will be vanished. So only this thing will be there. So the result will be 20 by R cube. Twenty by R cube sin theta cos phi sin theta cos phi AR cap dot. Now what is the differential line element in spherical system? Remember, I think it was only dr AR cap. So the result will be from R to 4 theta is equal to 30 degree constant, phi is equal to 120 degree constant. So your result will be coming as 20 by R cube sin theta cos phi dr. AR dot AR is vanishing at 1. So you need to integrate this R from 1, keeping theta is equal to 30 degree and phi is equal to 120 degree. Similarly, if you carry out I2, I am writing directly. So you see, if you carry out I2, you see only theta component will exist. So let me write it down directly, minus 10 by R cube minus 10 by R cube cos theta cos phi. Cos theta cos phi f theta cap dot. Now I2 is, you see, dl theta. So dl theta, you know, r d theta a theta cap. So integration limit should be from theta is integrating from 30 to 90, 30 to 90. R is constant at 4 and phi is constant at 120. Similarly, if you integrate I3, then your integration limit would be phi from 120 to 60. I believe 120 to 60, right? 120 to 60. Now in this case, you see only phi component will exist, so you are only write 10 by R cube sin phi, 10 by R cube sin phi, 10 by R cube sin phi f phi cap, and you know dl phi is nothing but r sin theta d phi phi cap, and in doing so you need to evaluate this as r is equal to 4. You need to keep r is equal to 4 constant and theta is equal to 90 degree. So if you integrate these three, and then if you multiply it with the 10 microcoulomb, your ultimate answer will come, your final answer will come. You see, everything has been done here. Okay, so your final answer will come 28.125 microjoule. It will come 28.125 microjoule. Okay, so you see, in this expression, in this big thing, everything has been done. Whatever I have written in this slide, so everything has been written here. Okay, everything has been written here. So you go through this, and this is how you solve these problems. Okay, this is how you solve this problem, work done problem. So I am keeping it here today. So if you have any query, you can ask me. Please, if you have any query, you can ask me. So if there is no query, then we can stop the session here.